Motion of object on inclined plane, rough inclined plane. So let us go with this. Suppose that there is an object of mass m is kept on smooth inclined plane. Then if I am keeping an object, what is the acceleration of the object is? G sin theta. Do you remember? What are the force acting? mg will act downward, normal action will act perpendicular to incline. If I am extending this angle will be theta. Then what are the components? The components are mg cos theta. The other component is what? mg sin theta. What will cancel out? Normal action will cancel out with mg cos theta. Normal action is mg cos theta. Then what is the force? What the resultant force acting on the object is? mg sin theta. Because of mg sin theta, the block will accelerate downward. So what is the net force acting on the block is? Net force acting on the block is mg sin theta. Then what the acceleration of the block is? Acceleration of the block is g sin theta. So you keep any object, that object will come down with what acceleration? G sin theta acceleration. This is on smooth inclined plane. Okay, na? Now same thing if I am keeping on a rough inclined plane. This is a rough inclined plane. Okay, I am keeping the one object of mass m. Object of mass m. Then same story. mg will act vertically downward. Normal action will act in this way. Then what are the components? The components of weight. mg sin theta will act down the incline. mg cos theta is balanced with the normal reaction. All of you okay na? Then what is the normal reaction value is equal to mg cos theta. No problem till here. But if theta is less than angle of repose, if theta, angle of inclination is less than angle of repose, the angle at which the block will slide or ready to slide on the inclined plane, angle where the block will slide down or ready to slide. So if you are keeping the less angle, what will happen? You know, as I am increasing the angle of inclination, then block will slide down. At angle of repose, block will slide down. Till angle of repose, block will slide down or not? So now angle of inclination is less than angle of repose, then block will be at rest or sliding down? Rest. Very good. Block will be at rest. If block is at rest, how the friction force will act? Friction force will act upward because mg sin theta is acting downward. Mg sin theta is the force applied and friction will act in upward sense. Then what the friction force value is equal to? Static friction will act in this case. If angle of inclination is less than angle of repose, static friction will act, which is equal to how much? Which is equal to applied force mg sin theta. Static friction is equal to mg sin theta because the object is at rest. Okay, na? As the object is at rest, static friction will act. Static friction is equal to applied force. What is the applied force is mg sin theta. If theta is more than angle of repose, angle of inclination is more than angle of repose, then what happens? Block will slide down. The block will slide down. What are the force acting on the block? mg sin theta is acting downward. mg cos theta perpendicular to incline. Okay, so mg cos theta is the other force. This is the normal reaction. Okay, na? And what is the friction is? Friction is will act upward, which is kinetic friction. So now mg sin theta will be more than kinetic friction. So that's why block will accelerate downward. Block will accelerate downward direction. Now what is the acceleration value? How to find out the acceleration value? To know the acceleration, we require the net force acting on the block. What the net force acting on the block is now? Mg sin theta minus kinetic friction. So net force I can write down is equal to Ma. Okay, na? Mg sin theta minus what the kinetic friction is? Mu k into normal reaction. Kinetic friction is having the particular formula, right? Static friction is not having the formula, but kinetic friction is having the formula. Static friction is equal to applied force, that's it. But kinetic friction is equal to mu k into normal reaction. So Ma is equal to mg sin theta minus mu k into what the normal reaction is? Normal reaction is mg cos theta. Normal reaction will balance with mg cos theta, perpendicular to incline. That is every time we are doing the same. Then what the acceleration value is equal to? Mg I can take it out, sin theta minus mu k cos theta by m. In these two terms I took the mg common. So sin theta minus mu q cos theta will left, sin theta mu q cos theta will left by m, then m will cancel out, then what the acceleration value is equal to g into sin theta minus mu k cos theta. This is the acceleration of the object when angle of inclination is more than angle of repose, and this acceleration is, can I say, less than g sin theta? Obviously no, g sin theta minus something is there. That means definitely this value will be less than g sin theta. Means block will have the more acceleration on smooth surface or rough surface. Okay, on smooth surface the object will have the more acceleration than rough surface.